Your app can be completely broken and Kubernetes will still send traffic to it. Users hitting 500 errors, APIs failing, database disconnected, and Kubernetes, it thinks everything is fine. If you don't understand this, you will ship outrage to production. Let me prove it. Hi guys, this is Shivam, and today we are talking about why Kubernetes sends traffic to broken apps. So one of the biggest misconceptions beginners have is that they think pod is running equals app is healthy. That is completely wrong. Kubernetes only checks if your container process is alive. It does not check if your application inside is actually ready to serve traffic. And that's the difference where production incident begins. Let's break this live on my kind cluster. First, I will deploy a simple Nginx app. So the kind is deployment. Name of the app is demo app. It has one replica. It is running an Nginx image and the container itself is running on port 80. Nothing fancy, a very simple Nginx application. Let's go ahead and deploy this. So our deployment got created and our pod is up and running. Now let's expose this deployment using a service. Here I'm using imperative command to expose our deployment on port 80. It says our service demo app has been created and exposed. Let's check our service. Okay, we have our service here. Now let's expose our service on port 80 so that we can access our application. I'm using port forward command. It says forwarding to this port. Now I will do a curl on localhost, and if everything is fine, I should be able to see the welcome page for Nginx. And we can clearly see welcome to Nginx, which is the welcome page getting served from our container. So till here, everything looks healthy. Now I'm going to break this app. Let me stop this. So let's break this app, not by crashing the container, but by making it useless. I'm gonna add a command inside my deployment.yaml file to remove the nginx.html file. I will add the command inside the container section, and remember guys, YAML is strict about indentation. I think this looks good. So if we look at this command here, it says remove the nginx default file. This rm-rf command is trying to remove the default index.html file inside this folder. So let me go ahead and save this, and we will replace our current deployment with the new one. So our deployment got replaced. Let's go ahead and check our pods. It says pod up and running. Now let's test this. I'm gonna again use the port forward command, and it says forwarding to this IP and port. Let's try to access the application once again using curl localhost, and we are getting 403 forbidden error. The application is clearly broken now. And here's the scary part. If I try to get the endpoints, clearly see that pod IP is listed here. So let's go ahead and verify if this is the correct pod IP. And we can see the IP matches here. So even though our app is broken, service is still routing traffic to it. And on top of that, it says pod is up and running. And the reason why it is happening because Kubernetes logic is simple. If container is running, then it must be ready to accept the traffic. And that's something dangerous. Now let me show you how a production engineer thinks. If this was production, user would see 500 error. Monitoring would show spikes, team would panic, and Kubernetes would show everything is running fine. You would waste hours debugging the wrong thing, like networking, ingress, or load balancer. But the real issue is Kubernetes doesn't know your app is broken because you never told it how to check. Let's go ahead and we'll try to fix our application using a concept in Kubernetes called readiness probes. So this entire failing of application is called the readiness problem, and this can be resolved by configuring readiness probe. So in simple terms, Kubernetes needs a signal that says, hey, the app is ready to receive traffic. If you don't define it, Kubernetes assumes that your app is ready by default, and this assumption causes outage. Now, before we fix this application, I'm gonna reset the app back to normal so that we can prove Readiness Probe actually protects traffic when things break later. So I'm gonna stop this and I'm gonna edit my deployment file and I'm gonna remove this faulty command. Let's go ahead and save this. We will reapply our deployment. Our deployment got created. Let's do a port forward. So our port forward is done. Let's try to access the application. And we are able to see welcome page of Nginx. So our application is now restored. Great. Now let's once again edit our deployment file, and this time I'm gonna add something called Readiness Probe inside the container. So let me copy the configuration and we'll go over it one by one. So I have added my Readiness Probe inside the container and I have corrected all the indentation errors. So let's go over this one by one. This Readiness Probe field. So you are telling Kubernetes, do not assume my app is ready just because the container is running. You are giving Kubernetes a rule to verify health before routing traffic. Without this, Kubernetes assumes that if the container is running, it is ready to receive the traffic. And that assumption causes outage. Now, what is this HTTP GET? This tells Kubernetes use an HTTP request to check readiness. Kubernetes supports three types of check: HTTP check, TCP check, and command execution check. For web apps, HTTP is most common. It means Kubernetes will send a request inside the pod. Now, what is this path equal to slash? This means Kubernetes will call the URL, which is http pod ip 80 for the health check. If it gets 200 or 300 in response, it means that the container is ready, and if the response is 400 or 500, this means the container is not ready to accept the traffic. So we are telling Kubernetes, if home page works, app is ready. If home page fails, remove it from traffic. This port equal to 80 is the container port and not the service port. Kubernetes will call the container directly. This initial delay seconds equal to 5 specifies that wait for 5 seconds after container restarts before checking. And why do we need this delay in seconds? Because some apps take time to boot. If Kubernetes checks too early, it might mark it as not ready, which is incorrect. So this is like a grace period. And finally, this period seconds equal to 5. This means that Kubernetes will do a health check every 5 seconds. So Kubernetes will continuously monitor readiness. If it fails, traffic stops. If it recovers, traffic resumes. This is dynamic protection. Alright, enough of the discussion. Let's go ahead and apply this file. I'm going to save it and we will reapply it. Okay, so our deployment has been replaced. Now the readiness probe is active. Let's go ahead and break the app again. Like earlier, how we simulated by deleting the index.html file, we will add that same command to replicate the issue. So I'm going to again edit the file, go inside the container section, and we'll add our command here. So again, this is the same command which we added earlier. We are trying to remove index.html page. I'm going to save it. We will reapply. So our deployment is replaced now. Now let's go ahead and we'll check our pods. Notice something important here. Even though the status is running, the pod is not in ready state. This is the key difference. Running does not mean it's ready to receive the traffic. Now let's go ahead and we'll check the endpoints. But before doing that, let's grab the IP address of this pod. So this IP address of this pod is this one, and we'll do a get endpoint. You see here, the pod IP disappears. Kubernetes has removed this pod from the service. No traffic is being routed to it anymore. And that's protection. Now Kubernetes is behaving intelligently because we define readiness probe. Let me clarify one thing. There are two types of probe. One is Readiness Probe, another one is Liveness Probe. Liveness Probe restarts container if it's dead. However, Readiness Probe stops traffic if the container is not ready. Many beginners configure only Liveness Probe, and that's not enough. Liveness Probe restarts. However, Readiness Probe protects your users. So now you have seen something uncomfortable. Kubernetes does not automatically know your app is healthy. If you don't configure Readiness Probe, it will send real user traffic to a broken container. And that's the worst part. Kubernetes will look healthy if pods are running, services are active, and there is no obvious errors. But still, users are failing. That's how silent outage happens. If you deploy to production without Readiness Probe, you are gambling with user experience. Running does not mean healthy. Never deploy without readiness checks. Next, I'm going to show you something even more important. How Kubernetes actually decides if your app should be restarted. Because in production, things will break and you need Kubernetes to react correctly. That's it for this video. I'll see you in the next one. Till then, keep learning.